Let's now move on to the second example, which is about the bank. So you will see 3 slides with 3 classes. So I'll rather maybe just go over all of them at once on my iPad. And then there are many points I mentioned in the slides that are actually very similar to what I said for the circled example. I will also mention that on the iPad, so you can also read the slides by yourself. Okay, let's now do it. For the bank example, we got 3 classes. Okay, let me now go from the account class over here. So we got the account class. Every account has 2 attributes, integer ID and also double balance. And we got the constructor, which will take some input for the ID, some unique ID. That's something the user will make sure they are unique. And then simply set the ID over here. And the balance will just got default 0. Okay. And then we got deposit and we got withdraw. Let's say we got 2 mutated methods. In the case of deposit, we just want to make sure you can never deposit, for example, minus 100. You cannot do that. It's got to be larger than or equal to 0. Let's say you can deposit $0 if you want to, let's say, okay? But if that's less than 0, you're going to say, very similar to the negative radius scenario. You're going to say system and out the print line, print out to the console, say invalid deposit, okay? And the method we're going to focus more will be the withdraw method. Okay? It's going to be double A over here, some amount. And we say that if the amount is actually negative, or, so remember this disjunction, if either one actually occur, it's going to be considered as an error. If the amount is actually less than 0, or if somehow the current balance hypothetically subtracted by the amount you propose is going to be less than 0, we will go below 0. That means the amount to withdraw is way too large. For example, if you only got $100 in your account, but if the bank allow you to withdraw maybe $1 million, that would be a very good bank, but I don't think that's going to happen in real life. So that should be also considered as an error. And then in that case, we're going to system out the print line, also invalid withdrawal. Okay, so that's the account class. And of course, if there's no error, we're going to do balance minus equal the amount. Okay, so account class is not too bad. And the bank class actually uses the programming pattern that we review in the first 2 weeks, right? So we're going to have an array of accounts, and then we got some auxiliary counter. So if you got any trouble with understanding this programming pattern here, please refer to the review tutorial series part 2, or you can get in touch with me. I'm not going to waste your time explaining the programming pattern again. Okay, so the also we got here so there is a little typo over here. So the constructor should be, let me just fix that quickly here. So this should be bank rather than account. But for the example code that you're given, it should be the bank rather than account, right? So you can think about the constructor for the bank is simply going to initialize the accounts array and also the counter appropriately. And we got withdraw from. This is very important. Whenever we want to withdraw some client's account with certain amount, that's what we will do. So we're going to give the unique ID for the clients. We can simply assume that, let's say in this case, the ID may exist in the bank, and then some amount. So we're going to go through the list of accounts starting from 0 until the number of accounts. We also explained that in part 2 of your review tutorial series. And then we say that if the current account we are looking at index I dot ID, you can either say dot ID or get ID. That might be better, right? But for now, just for illustration purpose, I'll say ID. Equals ID. I'm using equals because it's actually integer. So that's why I can do that. If there's a string value, you must use dot equals. Okay. Again, I'm assuming that there you can simply call get ID if you wish, like a public accessor. But for now, let's not worry about it. And then I'm gonna, if the account ID matches, I'm actually going to say account I, the I I'm looking at, and then say dot withdraw. So one thing that we also mentioned earlier, accounts I, this expression over here is of type accounts. So that is why I can call the withdraw method that comes from here, the account class, right? All right, so that's about the bank. Let's now go on to the next class, and then we'll build the call stack together, okay? So the next class I want to talk about is the bank application, which is a console application with the main method. So we're going to declare some scanner, and then, so here, we create object variable B of type bank. And then we're going to create account ACC1 of ID 23. Okay, only one single account. And then we're going to add ACC1 over here into the bank B. And we're going to read some double value from the console. So the user of the console application is going to tell you exactly how much they would like to withdraw from the bank, right? Which may or may not be valid. And we say b.withdraw from, so we're calling this method over here. And then the account ID should be 23. That means we want to withdraw from this particular account. Okay, and then this particular value that we actually read from the console. And eventually, we are going to unconditionally print out to the console transaction completed. So hopefully you can already see what the problem might be. In case we actually got some error over here because A might be negative, in that case, we would have already printed out the error message to the console to say invalid withdrawal. But after invalid withdrawal is printed out to the console, we are still printing out transaction completed to the console. So you got some contradictory messages to the console, right? That's something we already went over. I'm going to trace together with you on the debugger just to verify. But right now, I would like to just reinforce your understanding about the call chain, which is a very important idea. Let me now do that. Given that it's a console application, we know that the entry point of execution is the main method. Let's now start with that. Okay, so you can see the bank application is our starting point, and then in the main method we are trying to make the method call, right? So let's put a context over here. I'll try to fill in this table over here, and also I'll try to fill in the call stack simultaneously. Okay, so you can get both. So under bank application, the main method, so that's the context. So that'll be bank application. Okay, same bank app, and also the main method. I'll just say caller here. Of course, you will see that it's bank app dot main. Okay, so which method are we calling? You can see there are two methods being called over here. One is the add account from the bank. The other one is the withdraw from the bank. You can say that there are two callees over here, but I'm going to focus on this particular callee. That's more interesting. So for that one, we're going to put a different color. So we declare bank B and also b.withdraw from. So this is the callee, right? So we're going to put over here, callee will be bank dot withdraw from. Okay, so that's a callee. What about a call stack? Given that we start from here, so this will be the first method being made active. So that should really go to the top of the stack the earliest. So what we should do is we should really put here bank application dot main. So this is currently the top of the stack, right? As we put something more, they will become a new top, right? That's, again, it's a reverse chronological order. This will be the earliest method that we push onto the stack. Okay, okay, let's now switch the context to the callee. So now the context will be this particular class and method. So what I will do is the context will be bank right now. And then let me highlight it. So it will be the bank class, and we're talking about the withdraw from method over here, right? Let me write it down. And then withdraw from method. I can put it on the stack since now the control is switched to this particular method. So I can put bank dot withdraw from. All right. And then what about this particular method? You can see inside a particular iteration of the loop, actually for every iteration of loop, I should say, corresponding to the size of the number of accounts. In that case, I'm going to call withdraw. Let's see how we can do that. So it's going to be calling the withdraw. So now how do we work out what's the context class? The context method for the callee is withdraw for sure. So what about accounts I? Well, that's something I just mentioned. Accounts is of type account array. Each individual member at index I should be of type account, of course. So the context class should be account. Okay. We have also seen such inference back in the review tutorial. You can also refer to them. So what's going to happen is we're going to put over here. I can also highlight this account over here so you will know that's actually where I actually infer the type from. So this will be here callee will be account dot withdraw. Okay, and then of course as soon as we switch the context to this account over here, we're going to push another call to the stack. That'll be the new top, which will be account dot withdraw. Okay, so now we got three things on the stack. We got three methods on the stack, right? This is the earliest one. This is the latest one. And what about for this particular one? When we go to the account, once we go to the account, we go to the withdrawal method over here. Do we have any further method call? No, we don't. But let me just highlight it. So that'll be account class. And then we got a withdraw method, but no further call. So there's no further callee to be filled in, but we still need to fill in the context, which will be account. And then it's going to be withdraw over here. One thing to note, you can see, except for bank application, bank that withdraw from is both the callee and caller simultaneously. Account that withdraw is also the callee and caller simultaneously, right? Just notice that, right? But bank application is only the caller, it's not the callee at this point because that's already the entry point of execution. So it cannot be the callee of another method. Right? And then of course for this part here, we simply don't have anything because there's no further method call. And then you will see that as soon as we finish, let's say if we somehow run into some error, in that case, after executing this line, we will have terminated this method here and return. So that means the withdrawal over here will be taken out from the stack. And then in that case, we will go back to where we got suspended, which will be the current iteration. In that case, we might just go ahead and finish the rest of the iterations. In that case, we reach out to the end of this withdraw from method and we'll remove this context method as well from the stack. And then after that, we'll go back to the withdraw from over here, right? And then after that, we'll still execute system and other print line transaction completed. But the problem is, it is certainly possible you can print out both this message and this message. Read them together, you can see invalid deposit but transaction completed. They are both contradictory, right? So in that case, it's really not good to do it this way. Let me show to you very quickly about how to use debugger to see this. Okay. So the source code is already made available to you. So it's really up to you to actually play with them. It's really important for your understanding. Let me now switch back to the Java perspective, right? Apparently I got some typo over here occurs. Okay, let me fix that quickly. Okay, and then so what we're gonna have is we got if you go to another package, well, still the same projects, which is exceptions, circle, and bank. Okay, the same projects. Go to the accounts without exceptions. So that's the one with the console tester. And I want you to go to the console application, which is the bank application over here. And let's go over very quickly. We're going to create one account, ACC1, the same as before, but now we're going to set the balance of that account to be 100. Let me just clear the console over here so you don't really get confused. Clear, okay? And then once we created that account, we're going to say bank B, and then add ACC1 into that particular bank. And then we ask the user, we prompt the user to enter some floating point number. How much would you like to withdraw from the account? I'm gonna enter some wrong number, like a negative number. And then we're gonna call withdraw from, and then I will show you the call chain, and I'll show you what's gonna happen that's wrong. Okay. Let me now put a debugger. And what about we put exactly the breakpoint here? Okay, right before we execute b.withdraw from over here. Okay. Let me now move my cursor over debugger. So I'm going to debug bank application class. If I click on that, okay, again, don't worry about this line here. How much to withdraw from? So there's a prompted from this line over here. So let me enter some number. Let's say minus something. Let's say I want to say minus 5. I want to withdraw minus $5 from my account, right? Apparently that's wrong. Invalid. Let me say I want to go further. of course, I got to type enter over here, right? As soon as I type enter, so now the input will be red, and now I can switch to the debug perspective over here. So now I'm reaching this line, and then rather than stepping over, I want to step into to show you the call chain, okay? And notice that what's going to happen is, I want you to remind yourself, we are still in the context of this particular bank application domain. As soon as we step into, we're going to go into bank withdraw from, and then in some iteration, we're going to step into again to the withdraw. In that case, we'll switch the context into account that withdraw. So that will be the plan for showing you the debugger. Just keep that in mind, okay? So what's going to happen is, if I say step into, I'm going to switch the context to the callee, which will be bank.withdraw from. All right, let me now step into. So now I'm now in the withdraw from in the bank, right? That's exactly the table and the call stack I showed to you. And we got several iterations to run. How many? What's the current size for NOA? The number of accounts. You can definitely see that from under this. We see NOA is just one account, right? Just one iteration. So I would say step over and step over. And what I want to do now, remember the amount is actually -5, right? And we're going to step into again. And when we say step into again, we're going into accounts. I will be account dot withdraw. So that'll be the new callee we'll switch the context into. And the rest of the line will just be, the rest of the iterations will just be suspended until we return from this method call. Let me step into again. We're going to switch the context to account. Step into, so now we are under account and also withdraw, right? And the amount is simply just -5. -5 less than 0 is going to be true, meaning that the whole disjunction will be true, right? And we're going to say step over. So we're going to print out some error. As soon as I say step over, you can see on the console over here, we got invalid transaction. One more thing I want to show to you as well. You can see over here in the debug panel over here, you can see the call stack, bank application domain, bank.withdraw from, account.withdraw. It corresponds to exactly what we have just seen over here. So I do want to tell you that whatever we learn about the theory of call stack, it does have its practice in the Eclipse IDE as well. So that's something I want you to see the correspondence. All right, so now we are currently, this is the top of the stack, and this is the bottom of the stack, right? Okay, let's go to the top of the stack over here. If I say step over is going to the last line for the withdrawal, so now we're going to terminate the withdrawal. So that means this particular top of the stack will be removed from the stack, meaning that we're going to remove it from the stack. And after I say step over, only these two items will remain in the stack. Okay, let me now say step over. You can see now we only got the top, the new top over here. So that'll be bank.withdraw from over here, right? And let's now see what's going to happen. So now we're already at the end of the first iteration, right? So now we are now reaching the end. Remember, there was only one account currently, okay? If there are multiple accounts, you might have to go for more iterations, but not for this case. And we are reaching the end. As soon as I say step over, what's going to happen? What's going to happen is we already removed this account of withdrawal. After we terminated this method here, we're also going to remove it from the stack. So we got only this one as the new top. Okay. Let me say step over again. Okay, this is now the new top, right? Eventually, once we also remove this item from the stack, that means the whole program will terminate, right? Okay, so now this is the thing. We have already printed out invalid transaction, but the execution flow still continues as if there was nothing reported wrong. That's the problem, okay? So now you can see if I say step over, the console will still say, even though it's invalid transaction, but after withdrawing -5 from the account, now the new balance is actually 100. Does not make any sense, does it? Okay, so you can see by using console messages, the execution flow that actually was not interrupted will definitely cause some inconsistency to the user. For me as a user, I'll be very confused to actually see that even though the transaction was invalid, but we actually the transaction was still actually continued and saying that the new balance is 100, right? That's definitely not the way to go. We definitely deserve a better solution, which is using exceptions. All right, so that's about showing you in the debugger. All right, and then for the rest of the slides, that's exactly what I have just illustrated, right? The three classes. You should definitely go over the points yourself, and then also to review the iPad notes and recording if you got any trouble understanding. All right, so that's about the two examples of error handling. So now we should really formally introduce to you what an exception is in the next video.